Good morning, everyone. Today is the first day of the June. It's time flies. We already had we already have online distance learning for a pretty long time. It's actually more than 2 months. And I feel like we didn't post a new lesson for a pretty long time too. So today we are going to introduce another topic. This topic will give us a new perspective to look at the volume. And this topic is about Cavalieri's principle. So you may wonder, what is this? So let's quickly check the definition for Cavalier's principle. So this principle states that if two or more figures have the same cross-sectional area at every level and the same height, then the figures have the same volume. So it looks like it's kind of long and very confusing first time to read it. So let's check the picture. So as you can see, we have 4 objects here. So the middle one, the middle 2 here is actually very familiar. So this one is rectangular prism. This is the one we always see called cylinder. However, the other 2 here look like very confusing because this one is not like the regular one we see like a vertically perpendicular to the base side, but this one is kind of slanted, and this one is same thing too. So this principle tells us if you use, let's say, like a knife or like a slice to cut every single slice here, and every single slice they do have the same area. So even this is circle, even this is a square or whatsoever, or a rectangle, if they have the same area, so the area is the same, and also the height is the same for all the objects, then they have the same volume. So some students might wonder, how do we say the same height? So as you can see, the height for this two is actually from the center to the center, and this is a distance. The distance is height, same thing here. But for this one, some student might say, are we going to talk about this is the height? Because it seems that this height is same as this one, so can we say this is also the height? No. So if you put, like you put a pile of the book, like you push over a little bit, so it's not really straight up, then when we talk about the distance or we say the height, you have to consider is the center from the top side, top face, and also to the base area, so it has to be vertically perpendicular. So this will be our height. Then as you can see, they all have the same height. If that's the case, then you have the same volume, meaning even it look like this way, I can still use pi r squared times height to get this answer. Okay, so that's how do we use this, we call Cavalier's principle to get this. Next, I want to show you a quick, another example to look at this principle. So as you can see, this is two are different pile of the coins. However, the number of the coins is exactly the same. So if you look at this closely, this is actually a cylinder. So how many coins here? Each coin has the same volume, and then all the coins together is the volume of the whole thing. So this one, is like you push over here, you push over here. So it's like in a different position here. However, if every single coin has the same area, and of course same amount of the coins will lead up to the same height, so they too is actually have the same volume. So that means even you look at this one look like this, then you can still use this to find the same volume. So that's Cavalier's principle. I want to show you another examples and to have you so you can easily to see how do we transfer from this one to this one, or how do we actually look Cavalier's principle in the different cases. So let's check this one. So as you can see, this one is you can imagine this is like a pile of the books. So this is we know is a rectangular prism, and we know we can use length times width times height to find the volume. However, this one is curved like this. So how do we know the volume? As long as every single, you can see, is like a pie of the book of the cross-sectional area. It's like every single piece here is actually same, and also same on the book and same height. So if you just look at this, it's like, see, no matter how you push over, and if you just move back to this position, they actually exactly the same. So that's why we said Cavalieri's principle tells us no matter how you place this pile of books or this object in place in different way, they actually have the same volume. Another example here. So this example telling us for this, as you can see, this is actually a triangular prism. So the top one is a triangle, the bottom is a triangle. So the regular one, we know the base area times height is this one. But if you place a book in a different way, same idea, they actually have exactly the same volume. This is exactly why. Okay, so the higher or the deeper level of the reason of why here, so when you learn something about the calculus, then in the future you will understand exactly why for this kind of thing happening. Okay, so this is the good way to visualize this process, why they have the same volume here. So lastly, we are going to check one example to finish this topic. So let's check. The following part, we have two objects, and we are telling us, so which object has a bigger volume, or do you think they have the same volume? So, as you know, based on what we just learned about the Cavalier's principle, we know the base area, which is 3 times 4, and the height is the same, so 6, 6. So that means the volume is actually the same. So this volume can both, so we can say two objects. So this is our reason, have the same base area and the same height. So Cavalieri's principle. So this is actually what we observed. And this is actually the principle we learned can tell us, could guarantee this is happening here. So Cavalier's principle says they have same volume. And also the volume will be base area times height. So length times width, because it's just a rectangle. No, yes, rectangle. So 3 times 4 times 6. That will be our final answer. So they do have same volume, exactly same. And also one more thing I want to remind you, the height we are talking about for this one is actually the vertical distance from the top to the bottom side. It's not this side. Okay, so that's one thing. Okay, that's all for the lesson. We have more planned for this week. Please check Google Classroom closely, and if you do have any question regarding this class and how the grade, things like that, you can always email us. So stay safe, stay healthy. See you soon, everyone.